All right, we're on our seventh additional focus area. Today's objective will focus on the difference between distance and displacement, as we're talking all about movement in this focus area. So distance is a definition. I'll put it up here, but you probably don't need it. It's just how far something moves, how far it travels. It does not matter what direction it moves. For instance, if I were to get out of my chair right now, walk out of my house to the mailbox, it's about 25 feet away. Then I'd have to come back 25 feet to sit down. I've moved 50 total feet. 25 in one direction, 25 in another, but it doesn't matter. Distance does not matter in direction. So I just add up all the different distances I moved. Look at the little ant here. Notice where he's starting. Notice where he moved. And if we were to ask you what distance the ant traveled, it's super simple. Started at 0. He went all the way to 3. And since it's in centimeters down there, the ant would have traveled 3 centimeters. Didn't matter that he moved to the right. He traveled 3 centimeters. Since we've already said distance does not matter which way you're moving, which direction, here's our little ant again. And look, this time he started at 3. He moved to 0. Okay, it's still 3 centimeters. It doesn't matter that it was in the opposite direction as the last time. We said distance does not matter in direction, so he still traveled 3 centimeters. So let's follow the ant for the whole time. Ooh. All right, how much distance did the ant travel there? And the arrows are there to remind you of where he went. So the first arrow says we started at 0, and he went to 5. Then he turned around, and he went to 4 and 3. That's 2 more units. So 0 to 5 was 5. 5 to 4 was 6 centimeters, and 4 to 3, he moved a total distance of 7 centimeters. So you kind of have to use the timeline to get it right easily, because you can't just add the numbers on the ruler here. But he moved 5 in one direction, and then 5 minus 3 is 2, so for a total of 7 centimeters. All right, if we look at the ant in the second picture here, down at the bottom, well, let's look at the top one first. Why not do both? Top one, ant, starts at 0. The arrow goes to 5. All right, super simple. That means it went 5 centimeters. Those are the nice ones. This other ant started at 0, went all the way to 6, stopped, but we count that 6 because he did travel it. And then he went from 6 to 5, that's 1, 5 to 4, and 4 to 3. That's 3 more. So 6 plus 3 would be 9 centimeters for that second ant. Why does that matter? That seems too easy, too simple. Well, it is, but it's to show you the difference between distance and this new word, displacement. You probably knew the distance definition. You probably don't know what displacement means, at least in regard to this. You might know it in terms of like finding the volume of a weird shaped object by seeing how much liquid it displaces when you put it in like a beaker. But what we're talking about here is the difference between an object's final position and where it starts. So let me go back to my example before we show you some more of the ants. Earlier on the first slide, I said, if I get up out of my seat, walk out of my house to my mailbox, which is about 25 feet away, and then I walk 25 feet back and sit right down, the difference between my final position and starting position is 0. I ended up in the chair. I started in the chair. So my displacement is 0, even though I walked 50 total feet, 25 to the mailbox and 25 back. So displacement then does depend on direction, because all we care about is where do you end up compared to where you started. Sorry about the dog. So here are some types of examples you could be given. A positive and negative could be your direction. Positive just being one direction, negative being the opposite. It could be north, south, east, and west. So you walk 10 feet north, 5 feet east, 4 feet south, whatever. Or it could be an angle. It left at a 90-degree angle, turned to the right at an 80-degree angle. So let's give some distance versus displacement examples just to be familiar with how they look before we practice some problems. Example of distance, the ant walked 3 centimeters. Now that's not displacement because we said displacement has to include direction. So the displacement example would be the ant walked 3 centimeters east, or positive 3 centimeters, or negative 3 centimeters, or walked 3 centimeters at a 90-degree angle, whatever. It doesn't matter as long as there's a direction involved. So an object's distance traveled and its displacement can be the same, but a lot of times they're not. Let's go over some examples here. All right. So in this example, let's talk distance first. He started at 0. He moved a total of 3. So his distance is 3 centimeters. I'll just put DIST for distance. Displacement is where does he end up compared to where he started. So he ends up at 3. 3 minus 0 where he started. His displacement in this example would also be 3. So we said they can be the same, and they are in this picture. I was lazy. I'm sorry. I should have said positive 3 or 3 centimeters to the right for the direction. So I was a little lazy on my displacement myself. Sorry about that. The values can be the same, 3, but you do need to put that direction. Sorry. All right. Now, the distance, where did he start? He started at 3, and he went to 0. So his distance, I'm going to put dt for distance, is 3 centimeters. His displacement, well, it's still 3. He went from 3 to 0, but since he went to the left, if you look over here, the key, but always the left will be negative, I'll put pt for displacement, is negative 3. So in both cases, we knew how far he moved, 3 centimeters, but with displacement, we knew which direction he moved as well. All right, let's look at the distance and displacement of this ant. Okay, well, let's do distance first. Again, distance, I'm going to put dt. He went from 0 to 5, and then he went back 2 spots. So 5 in one direction, 2 in the other. All right, so the distance he moved was 7 centimeters. Now dpt for displacement. Where does he end up compared to where he started? So I don't care about this stuff now. He ends up at 3. He started at 0. He's to the right of 0, so it's a positive 3. Remember, the key for displacement is where do you end up compared to where you started. So while this ant moved 7 total centimeters for his distance, his displacement, meaning where does he end up compared to where he started, is only 3 centimeters to the right or positive side. All right, let's take this example. An athlete runs around a track that is 100 meters long 3 times and then stops. What is his distance and what is his displacement? So this guy goes around once, around twice, around 3 times, and finishes right where he started. So his distance is the total amount of movement. We said he went 100 meters 3 times. So we'll just add them up, 300 meters. His displacement, where does he end up compared to where he started? Well, same place. So his displacement is 0. He ran a lot. He's probably tired. He hustled, ran 300 meters as fast as he could. So his distance was nice, 300 meters, but his displacement is 0. He ended up where he started. So that's how you get a displacement of 0, even though you moved. All right, let's look at these 2 practice questions. Up here, you have to read carefully if you see a question like this, which you might on your content assessment. So we started at 0. Green shows step 1, and then step 2 here is in blue. So let's do dt for distance. And just literally, if you want, it's the easiest way is to count the number line. For distance, 1, 2, 3, 4, 5, 6, 7, 8. So the distance is 8 whatever. It doesn't say up there, so I'll pretend it's still centimeters. All right, that's his distance. Displacement. Remember, the displacement is where do you end compared to where you start. He starts at 0. He ends at 4. It's to the right, so it's a positive. So his displacement is positive 4 centimeters because he is 4 centimeters on the positive side of where he started. Yes, he moved 8 centimeters. He moved 2 one direction, then 6 the other. So that's 8 total centimeters for his distance, but he only ended up 4 spots, 4 centimeters from where he started. So that's where we're looking at. All right, this picture's a little harder to kind of understand. You got to look at the times. So that means if this is the 1 minute mark and 0 and 2 and 3, that means from 0 to 1 minute, he went all the way here. And then from the 1 to 2 minutes, he went here. And then 2 to 3, he went here. Let's just figure out displacement because I don't want to have to add all those directions up to find the distance. We could, but we'll save some time and look at this new topic of displacement because in this distance, it's a lot easier. Displacement is, again, where he ends up, which is here. This is the last part we went to, compared to where he started, which was here. So 0 to 120. It's to the right, so we make sure we put that positive sign, and it's 120 whatever centimeters